There it is. Okay, there it is. All right, so now we are on the last part, paper 2, section B. Yay! Okay, so paper 2, section B was a total of 11 marks. And so here we go. Okay, so it gives you a cardboard box. I really liked this problem because it kind of incorporates some like old math 3 stuff. Okay, and this is number 1. It's the only problem in this section. So a cardboard box is in the shape of a rectangular prism, length x, width 3/2 x, and height y. So first it says write down an expression for the volume of the box. So remember, the volume is length times width times height. So just like put all those things in there. So we should have x, we should have 3/2 x, and we should have y. So that's our volume formula, and that's all you needed. It was 1 mark, so you get +1 for that answer. Okay, so that's part A. Part B says write down an expression for the volume of the box. Oh, sorry. Then it says the total volume of the box is 1,000 centimeters cubed. So 1,000 should be equal to my x times 3/2 x times y. Then it says find an expression for y in terms of x. So basically, when it says find an expression for y in terms of x, it's asking you to solve for y. So get all the x's on one side, y totally by itself. So all you would have to do is I would just distribute this. So 1,000 equals 3/2 x squared y, then divide by 3/2 x squared. So then y should be 1,000 times 2 over 3x squared. Because this 2 is in the denominator of 2 things, it flips up to the top. So you should end up with, let's see, 2,000 over 3x squared. All right, and that should be your final answer. This was also only 1 mark, so you get 1 mark for just having the final answer correct. Okay, and you need to show your algebra here, just to see what you did. And then also you could have converted this to 1.5 if you wanted to avoid the fractions. Now, part C says show that the surface area of the box is given by a of x equals 3x squared plus 10,000 over 3x. So this says it doesn't say that it doesn't have a top. So there should be 2 types of each side. There's the top and the bottom should be the same. The left side and the right side should be the same, and the front and the back should be the same. Okay, and each of those will have separate types of dimensions. So our a of x should be 2 times xy. Basically, we have the combination of each of the 2. It's like a combination of 3 things, choosing 2 at a time. Okay, so 2 times x times y plus 2 times 1.5x times y plus 2 times 1.5x times x. So we have all the different combinations of the length, the width, and the height, having 2 of them in each thing, and then we have 2 of each of those sides that will have those dimensions. And remember, this is area, so I should only have 2 dimensions multiplied in each term. Now I rewrote this because we don't want to have y's in here. We just want to have x's. So I have 2x, and then I need to replace wherever there's a y with this 2,000 over 3x squared. So I should have 2,000 over 3x squared right here. And then plus 2 times 1.5. I'm going to go ahead and do, I think 2 times 1.5 is just 3. So this should be 3x times 2,000 over 3x squared, and then plus 3x squared. Okay, now we need to do a little bit of combining. So I should get 4,000 over 3x right here, plus 6,000 over 3x right there, plus 3x squared. This is looking super promising because it's very similar to the answer. Combine these guys, 4,000 and 6,000 gives me 10,000. I can do that because they have the same denominator. And now we have almost exactly what I had to solve for. Okay, this was only 2 marks, so you get +1 for getting to the final answer and +1 for your method. This includes your setup and like your algebra all the way down, mostly your setup, and that's that. Okay, that was part C. Part D says find a prime of x. So we definitely want to use our simplified version to do this. A prime of x should give me 6x right here. And this one should give me, so this is really 10,000 over 3 times x to the -1 power. So really what we're going to have here is negative 10,000 over 3x squared when I take the derivative. I subtract 1 from that power, giving me -2, and then I need to multiply by my first power, which was -1, which gives us that negative sign out front. So that is part D, and part D was worth 3 marks, and you just get +3 for correctly differentiating the entire thing, okay? So maybe like 1 for this correct first term, 1 for the correct second term, and 1 for the correct sign in the middle of the 2 terms. Okay, so that's those 3 marks. Part E, find the value of x which makes a of x a minimum. So this one is a little bit more complicated than I think it should be. Actually, no, it's not, because this is calculator active. I kept forgetting that and consistently do that a lot. So all you have to do, I took the, I took that derivative and set it equal to 0 and solved, and then used the second derivative test and the first derivative test to verify that it was a minimum. But you don't have to do that. You can do this the easy way by taking, so it wants us to find the value that makes a minimum. So we're taking the derivative of a and setting it equal to 0. So we take, and we could do this 2 ways. We could stick a in your graphic calculator and actually look for a minimum, or you can stick a prime in your calculator and look for a 0. They're both like pretty much the same thing. I'm going to stick a prime and look for 0. So 6x minus 10, I should put parentheses, 10,000 over 3x squared. And graph it. Oh, I'm going to have to change my window for sure because it's going to be super gross. My x value, though, shouldn't be that far off. So I'm going to do -10. That should can get my x value, and I'm going to do like 1,000 and -1,000. Make this oh, window. What did I do wrong? Oh, that's it. This should be -1,000, and this should be +1,000. I'm sorry about that. Okay, so here it is, and you can see it right here where that becomes a 0. Now you can verify that this is a minimum because it's negative, it's below the x-axis, so going down in the original function, and then it goes up above the x-axis going positive. So you can see that if you set up a table, you would have, okay, and this is f prime of x or a prime of x for this problem. We know that we have a 0 and we can calculate that 0. So our left of the 0 is there. Our right of the 0 is maybe there, and we can guess. Our 0 is at about x equals 8.22. Okay, this is where it's 0. Now to the left of that, no matter how far we go, we should have, oh, oops. I want to trace. I have a negative y value. No matter how far I go to the left of that 8.22, I should have a negative. So less than 8.22, and I have a negative number. Now, if I go to the right of that 0, I get a positive number. So bigger than 8.22. And this is not the only 0 we can find. It's the only 0 in the domain that they give us because we can't have x values less than 0 here. But for the domain that we're given here, which is positive x values, this is the only 0. And if we go to the left, we get negatives. If we go to the right, we get positives. So we do indeed have a minimum. Okay, so this is from our graphic display calculator, from where we graphed a prime of x, and this is x equals 8.22. Sorry about that. Okay, so in part E, that's why it's only 2 marks, because you can just literally put it in your calculator. So you get +1 for your answer and +1 for like some sort of reasoning. On the PDF that I'm putting up for you, I put +1 must check to make sure min. That means just like you have to check to make sure that you do have a minimum. And so you can just write that you use your graphic display calculator and show this table or show this diagram and explain that because these values are less than 0, below the x-axis, we'll go down and then we go up on the original function. Okay, so that's that. And then for part F, maybe I can fit it on one page. It says find the minimum surface area of the box. So to find the minimum surface area, we sub in this 8.22 value. Oh, I actually solved for the value on my original solution and then subbed it in. You can use the estimate, it's fine. So we would take our original function a and sub in 8.22. The exact value is the cubed root of 5,000 over 9. You can sub that in as well. Either way, my area function is 3 times 8.2 squared, sorry for my computer constantly going off, plus 10,000 over 3 times 8.22. And you should get about 608.22. 608.22. And the units here, this is surface area, and it gives us this in centimeters. So centimeters squared. I did not include that on my solution PDF, so I apologize, but you would get +1 for demonstrating that you're subbing in that 8.22. So that would be 1 method point. And then you get 1 point here for your answer. That includes units. And those units have to be centimeters squared. So if you didn't get the units correct or you didn't include them at all, then give yourself half a point for that. Okay, that is all. I hope that wasn't terribly confusing. And that you guys are having a great day. And I'll see you guys later.